Today we're going to go over 6 settings that control the quality, appearance, and performance of the volumetric cloud system in Unreal. Let's go! The cloud settings that we're going to look at today are scattered all over the UI in lots of different places, so I wanted to make sure that you're aware of all of them and where to find them. After going through this video, you should have a pretty good grasp on how to get a good balance between visual quality and fast performance of your clouds. In order to measure the performance costs, we're going to be using the GPU stats, and you can find that by coming up here under this menu, selecting Stat, Advanced, and then scrolling the list down and checking GPU. And when you turn this on, you're going to also want to make sure that Show Stats is checked, because that'll toggle on and off all of the stats that you have visible. Okay, so with GPU checked, you can see that we have a big list here of all of the things that the GPU is calculating, and the list is sorted in order from the slowest to the fastest. So if we look at our list here, you can see that volumetric clouds is kind of toward the top of the list, and that we're getting a score of about 2 milliseconds. So that's a good baseline. That'll show us how much more expensive we can get and how much cheaper we can get with our clouds. In addition to watching the volumetric cloud metric here, which is right around 2 milliseconds, we're also going to want to watch our total scene time. Right now it's at about 22.6, 22.7. Well, it's bouncing around a little bit, but you can see that it's right around 22.7. But if I come over here to our world outliner and toggle volumetric clouds off, you can see that now it's dropped down to 19.7, which means that by turning our clouds off, we actually dropped about 3 milliseconds of time. So even though our metric said 2 milliseconds, when we turned it off, our scene sped up by 3, which means that some of the cost of the clouds is also hidden among some of these other metrics. So when we're measuring the total performance cost of the clouds, we need to make sure that we keep our eye on both the total scene cost as well as the volumetric cloud cost. All right, so let's jump right in and start taking a look at some of these settings. The first setting that we're going to look at is located here on the volumetric cloud component itself, so it's really easy to find. If we come down here to layer, you can see that we have layer bottom altitude, which is currently set to 5 kilometers, and we have layer height, which is set to 10 kilometers. And these controls control where the clouds start in the sky, and right now we have them set to start 5 kilometers above us, and then how high they actually go, and we currently have that set to 10 kilometers. And understanding how to set this requires just a little bit of knowledge of what clouds actually do. So let's take a look at a website really quick. You can see on this web page, which is Cloud Atlas, the World Meteorological Organization, they have this handy dandy chart here, which shows us that at temperate regions, low clouds go from 0 to 2 kilometers, medium clouds go from 2 to 7 kilometers, and then high clouds go from 5 to 13 kilometers. So minimum of 0 kilometers and maximum of 13 kilometers for our clouds. You can see that it also depends on what type of clouds we're dealing with, whether it's cirrus, nimbostratus, cumulonimbus, lots of different cool types of clouds here, but they all have their own ranges. So it depends on what type of clouds we're trying to imitate. Currently, you can see that our clouds are going from 5 to 10 kilometers. Let's see what happens if we increase this. Let's go to 0 kilometers. And then make our maximum clouds go up to 13 kilometers. Let's see what that did to our performance. Obviously, it changes the visuals of the clouds, but if we come over here to volumetric clouds for performance, you can see that our our performance dropped down just a little bit. So maybe this didn't have a very big impact on our performance. Let's maybe set our bottom altitude to 2 kilometers and our height to 13. This didn't seem to increase the cost of the clouds very much. We're still at 22.7 and 2.07. So we have a little bit of latitude to increase this height. Let's see what happens if we bring this height down to 5 kilometers. See what happens with our performance here. You can see that now we've reduced the cost of our clouds from 2 to 1.6 milliseconds. So we've brought our cost down by about 0.4. So that's a good savings. So you might want to consider, how small of a height can you get away with? Obviously, if you increase your cloud volume to the maximum range, you can get the nicest visuals. But if you want to save on performance, you can reduce the range of these clouds. Maybe we'll set this to a bottom altitude of 4 kilometers and then a height of, 3. And you can see that we now get these really thin clouds, but our cost comes down to 1.4. So now we're saving, a little over half a millisecond on our cost. So this is a trade-off here where you have to decide, how much realism do I want versus how much cost do I want to be able to pay. And some of that also comes down to the type of clouds that you want. If you don't mind just getting thin clouds like this, the smaller you make your cloud volume here, the better performance you can get. All right, let's set these back to our defaults. And obviously the defaults are set up to make the clouds look really beautiful and dramatic, but they're also a little bit more costly. So like I said, you might want to tune these down just a little bit to save on some cloud performance. All right, the next setting that we're going to look at is called light multiple scattering. And it's kind of hidden just a little bit. If we select our volumetric cloud component here, and then we come down here to cloud material, I can open up the instance of the cloud material and then double click on the parent to get to the material itself. So here's our cloud material. And we're going to go over this material itself in the next video, but if we zoom in here, you can see that this material has both a root node and another new node called Volumetric Advanced Output. And this is something special for volumetric materials, including clouds. So if we select Volumetric Advanced Output, come over here to this panel here, you can see that we have this category of settings called multi-scattering. And we have this setting here called multi-scattering approximation of octave counts. And it's currently set to 1. Well, what happens with clouds is that light hits the surface of the water droplets in the clouds, and instead of bouncing off, the light just continues through those droplets and gets scattered all around. And in Unreal, the way that we simulate that is by using multiple octaves or multiple steps of calculating this light scattering. Well, you notice here by default, our multi-scattering is set to 1. And that's because increasing these octaves has a pretty significant performance impact on the cost of our clouds. So if we look at our GPU cost here, we can come over and see our clouds are currently taking about 2 milliseconds. Well, let's turn our multi-scattering approximation octave count up and see what it does. You're going to see that it increases the visual quality of the clouds, but also increases the cost. So I'm just going to hit save here. And then we're going to move our material out of the way just so you can see what it does. And you can see that our visuals are increased dramatically. Like these clouds look significantly more realistic because Unreal is now calculating multiple steps or multiple octaves of light scattering in the clouds. But if we come over here and take a look at the cost, our clouds now cost 2.3 milliseconds instead of just 2, and our overall cost has jumped to 23.5 milliseconds. So that's a pretty significant performance hit to be able to do multiple octaves of light scattering. You can see that we do get a pretty significant visual upgrade though. So you'll need to choose again between 1 octave, which is better on performance, or 2 octaves, which is significantly better on visuals. Unreal recommends using 1 octave for real-time, such as games, and using 2 octaves for more high-quality presentations where frame rate isn't quite as important. All right, so let's set this back to 1 octave and save it and move on. The next setting that we're going to look at has to do with how the clouds cast shadows on themselves. There are 2 different methods that we can use for calculating how much shadowing is happening inside the cloud volume. One of the methods is called ray marching, and the other method is called Beer shadow maps. So if we come here to the cloud material again, and come down here to the options section, you can see that there's this setting called Ray March Volume Shadow. And ray marching basically casts rays into the volume, and all along the ray, it takes samples to see if that particular portion of the volume is shadowed by cloud structures. The other method uses shadow maps to see if the cloud is shadowing itself. Ray marching is a little bit more expensive and also higher quality, but using Beer shadow maps also works pretty well and costs significantly less. So let's take a look at the impact of ray marching versus shadow maps. So here you can see again we're about 2 milliseconds, and we're currently using ray marching. If we turn ray marching off and hit save on our material, now you can see we're using Beer shadow maps to calculate the cloud lighting, and it's made our clouds look a little bit more ominous. But you can see that our volumetric cloud cost has dropped significantly from 2 milliseconds down to 0.4 milliseconds. So doing that ray marching to calculate those cloud shadows was costing over 1.5 milliseconds, which is pretty expensive. Now you can see there is a little bit of an artifact here going on with the light flickering, so you may want to tune some other things to see if you can get rid of that. But if you don't mind clouds that have this visual style, you can save a significant amount of performance by turning off ray march volume shadows on your volumetric shadow material. That's a pretty big savings. By default, Unreal has them on, so let's turn them back on, and we'll take a look at the next setting. So now we're going to take a look at cast shadows by clouds, and to do that, we need to come over here to our scene's directional light. So I'm going to select the directional light, and in our case, obviously, this is referring to the sun. And we're going to scroll our properties down here and come to the atmosphere and cloud section. You can see that we have our atmosphere sunlight turned on. And if we toggle that, obviously, we're going to have no light left in our scene. So we need to leave that one on. We have cast shadows on clouds, cast shadows on atmosphere, and then cast cloud shadows, which means the clouds themselves are casting shadows into the scene. Now, right now we have cast shadows on clouds and cast shadows on atmosphere turned off. And the reason for that is, in order to see this, you really need to be above the clouds and have something in your scene that's large enough to cast shadows from the sun onto the tops of the clouds. And that's not something that we're really seeing in our scene. So we have these turned off mostly to save on performance. Let's turn them on just briefly and see what kind of a performance increase we get. So previously we had about 2 milliseconds costing for our clouds, and now we have about 2.1 milliseconds. So that increased our cost a tiny bit, but since we didn't get anything from that setting at all visually, we should probably just keep these turned off just to save a little bit of performance. The last setting we have here is cast cloud shadows, and we'll turn that off. And now you can see our scene is brightened up significantly because the sun in our scene here was kind of behind the clouds, and the clouds were casting shadows into our scene. And so that's pretty dramatically affected the appearance of our scene. And if we take a look at our performance here, you can see that it hasn't really impacted our performance very much. So maybe these cast shadows by the clouds don't really have much of a cost. If we take a look at our total scene time, while we're casting shadows from the clouds, we have about 22.7. And if we turn off the cloud shadows, we have about 22.6. So there's a little bit of a performance savings there, but not a whole lot. And there's a pretty drastic loss in quality when we turn off shadows cast by the clouds. So we probably want to leave that one on. All right, the next setting that we're going to look at is actually on the skylight, and it's called Cloud Ambient Occlusion. So if we select our skylight and scroll down here to the atmosphere and cloud section, you can see that I have this cloud ambient occlusion. And what this is it's light from the scene bouncing around and hitting the clouds, and then using ambient occlusion to determine how much of that light is actually going to light up the clouds. Well, let's see what cloud ambient occlusion does to change the visuals and also the performance of our clouds. So right now we've got cloud ambient occlusion on, and if we turn it off, you can see that our clouds lit up just a little bit because they're not being occluded by ambient factors in the scene. So there's more light actually getting to the clouds. And this actually might be a visual quality that you want. So you may want to leave this off because you like the way that it looks. If we come over here to look at our cost, looks like it's decreased by a tiny bit, but it's really hard to measure that small amount. So maybe that really didn't change our cost very much at all. But you can see that as I toggle it on and off, the clouds get brighter with it off and just a little bit darker on the bottom with it on. We're at 2.07, maybe 2.08 with it on. And then if I turn it off, we're at about 2.05. I don't know, it's fluctuating a little bit, so that amount of change is kind of hard to see. Maybe the cloud ambient occlusion doesn't really affect the performance all that much. So I actually think the clouds look a little bit more dramatic with it on, and so we're just going to stick with it on for now. All right, the last setting that we're going to look at today is called Use Per Sample Atmospheric Light Transmittance. It's again here on the Volumetric Cloud component. And what this does is basically Unreal calculates a global value for how things should be lit in the environment. And that's what it's using to light the clouds right now. But instead of using that global value, we can use per sample atmospheric light transmittance, which basically means every sample that we shoot into this volume is going to be calculating its own light transmittance value instead of using the global value. So if we turn this on, you can see that it has a pretty big impact on the visual quality of the clouds. The clouds look pretty cool this way, but I don't know, it could be either way for me. If you prefer the way the clouds look when it's off, you could use it like that, or you could turn it on and use it like that. Now, as far as performance goes, you can see that our cost has jumped up to 2.1 milliseconds instead of 2, so it costs maybe a little less than 1/10 of a millisecond to have this on. So there is a little bit of a cost there, but you'll have to decide, again, which of these you prefer. All right, to end off this section, what I want to do is turn on and max out all of the settings that we've talked about and see what kind of a maximum performance we can get our clouds to cost. And then I'm going to turn them all off and see how cheap we can get our clouds, just so you can see what kind of a performance range there is with the volumetric clouds feature. Okay, so first of all, I'm going to turn them all on, and we'll take a look at what that looks like. All right, with all of the settings, like as expensive as I can make them, you can see that our volumetric cloud cost here is at 2.7 milliseconds, and our total frame time is at 23.4, 23.5. So this is about as expensive as I can make them. Okay, now I'm going to tune all the settings to be as cheap as I can be and see what kind of a performance cost we can get there. All right, so now I've turned off shadows and ambient occlusion and ray marching and all of the fancy bells and whistles, and I made my cloud volume kind of thin. And you can see that now I'm getting a cost for the clouds of 0.38 milliseconds, and my total frame time has gone down to 20. So I'm saving almost 3 milliseconds by reducing these settings. So I guess the point that I wanted to make is that there's a huge amount of range and flexibility in how expensive you want to make your clouds. And if you feel like your volumetric clouds are just costing too much performance, there are a lot of knobs and buttons that you can tune to turn down the cost of the clouds and still use the cool looking volumetric cloud effect in your scene. So be sure to take a look at these settings, try tuning them yourself, and see what kind of a balance you can get between the cost of the effect and the cool looking visuals that come from having volumetric clouds in your scene. Just as a point of reference, I'm using a GeForce RTX 2070, and so your overall costs may be different on your machine depending on if you have a more powerful or less powerful video card. But kind of the point that I wanted to make here is that there is a large range, not necessarily the specific numbers that we're looking at here, but there is a really large range in performance and also visuals that we're able to achieve with the volumetric cloud system. All right, I hope you enjoyed today's video. If you have any questions on this system, be sure to post them down in the comments and I'll do my best to answer those. Next week, we're actually going to be taking a look at the cloud material itself, kind of breaking down how this works and maybe building up our own material, starting with one that's a little bit more simple and then maybe getting into one that's a little bit more complex. So I hope you come back next week for that one. Thanks a lot for watching, everybody, supporting the channel. We'll see you next week.